gives me a glitch saying that it records video but not audio, and I don't want that. I need both. Okay, so we'll combine like terms. 2 cosine squared theta plus 5 cosine theta 3 minus 1 is 2. And we are in the same situation as a few minutes ago. But this time we have to factor 2 cosine squared plus 5 cosine plus 2. How do we factor this, please? Take a moment and factor it. Can anyone give us the factored form for 2 cosine squared theta plus 5 cosine theta plus 2? Anyone, please? Anyone? Yes?
2 cosine theta plus 1.
2, I don't have enough room. 2 cosine theta plus 1 indeed.
And then cosine theta plus 2.
Excellent, very good. We can check, 3 seconds. 2 cosine squared, yes. 4 cosine x plus another cosine x. Perfect, 1 times 2, 2. Excellent. So, cosine theta plus 2. Perfect. So then we have 2 options for cosine theta. And you should say, not so fast. So what are the options for cosine theta?
-1/2 and -2.
Yes. Is this possible?
No.
Cosine is a bounded function. It cannot be less than -1, and it can never be more than 1. So this is not an option. So we only have cosine equals -1/2. We know cosine is negative in which quadrants? Can anyone tell us which quadrants is cosine negative?
The second and the third.
Very good. Here and here. And 1/2 has to be the reference, I mean, the cosine theta, the reference angle has to be 1/2. So that's only pi over 3 as we just had. Oh, I went too far, sorry. I should have gone in the middle, right here. Because it's -1/2 right here, right in the middle. This piece has to equal this piece. Okay, so this is the first angle, and this is the second angle. And the reference angle has to be pi over 3. We know that. So then what angles are there that I have to write? I hope we never run out of whiteout. It will be a tragedy for me. I'm kidding, of course. Okay, so what angles are we talking about? Both of them in the second and the third, and both have a reference angle of 1/3. A reference angle of pi over 3. Good. Can anyone?
Pi over 3.
So remember, this is pi. Pi minus pi over 3 and pi plus pi over 3. So what are they? So pi minus pi over 3 and pi plus pi over 3. Pi minus pi over 3 is
2 pi.
Oh, very good. And the other one, pi plus pi over 3, is
4 pi,
Excellent. This is it. Great job. Okay, I think we can put chapter 6 to rest. And let's continue with chapter 7. So where are my handouts? I think they're here. Okay. So I'm going to close this up and continue with 7.1. So we have, now we're looking at right triangles. Oops, I didn't mean to do that. And we will discuss how to solve a triangle. By solving a triangle, we mean find all angles on all sides. And then we're going to apply it in a couple of word problems. Okay. So this is 7.1, right triangle. Right triangles. So as we know, a right triangle has two acute angles and a 90-degree angle. So this is an angle and this is another angle. These are the acute angles. This is the right angle. This is the hypotenuse, and these are the legs. The two legs form the right triangle, the right angle, of course. Okay, and what we know here, depending on how we want to denote those, but it doesn't matter, the notation is not important, but what is important is if I denote the right angle by uppercase C, the opposite side has to be denoted by lowercase c. If this angle, let's say, is the uppercase b, the opposite side must be denoted by the lowercase b. And of course, if this acute angle at the top is denoted by uppercase A, the opposite side, in this case the opposite leg, has to be denoted by the same letter but lowercase. So this must be it. Okay, so I'd like to look at the first problem. Again, I let you choose at any point in time if you want to choose. But it says B is this, the angle A is this, find the rest. Lowercase b is this, lowercase c is this, find the rest. Okay? Now, this book uses this particular notation. So for some reason they didn't say, but this is the angle C, uppercase C. So we're gonna, to make sure that this is clear, if I put a problem like this, I will show you the triangle, or I will say the 90-degree angle is denoted by such and such. Okay, but for now we'll stick with this notation as we see it here, of course with uppercase C here. Okay, so they're telling us that B equals 6, angle A equals 20 degrees, and they're asking us to find the rest. Okay, fine. So I'm not going to write it here, I'm just going to copy it. So they say angle A is 20 degrees. So this is A, this is B, and this is C, and this is 20 degrees. The opposite of B must be B equals 6. And what we don't have is, we don't have the hypotenuse. We know that this is 90 degrees. We do not have angle B, and we do not have the opposite leg. So the hypotenuse has to be determined, the leg has to be determined, and the angle in between of these two, the hypotenuse and this leg, which is angle B. So it's clearly stated one more time. Find A, lowercase a, find lowercase c, and find the angle B. So this is the opposite of A is lowercase a. The opposite of C is the lowercase c. And of course, this is angle B. All we know, angle 20, angle 90. Can anyone give us angle B immediately?
70.
Of course, because 20 plus 70 the sum has to equal 90. Why? Because 90 plus 90 has to equal 180. So that is very clear. So now we have to determine the leg and then the hypotenuse, or the hypotenuse and then the leg. It doesn't matter. The order is not important. So do you have any idea for either one? And we have to use trig and trig functions to determine the rest. Okay, so let's determine one of the two, either A or C. Which one do you want to start with? It doesn't matter.
A.
Good. So we want to determine A. So we have to use a trig function that involves this and this, because we don't have C. Is there a trig function that we can use that involves this unknown as well as this piece? And for
Tangent.
yes, for which angle?
You can do any of them.
Correct. Let's choose one. Correct.
70.
Okay, so then tangent 70 equals what over what? Perfect.
Six over A.
So
Or
yes, correct. Opposite over the adjacent, 6 over A. Remember, this is a proportion, because this is over 1. In a proportion, you can always do this, or cross multiply. So A equals 6 over tangent 70 degrees. Are they telling us about any approximation? Do they want using, they don't say anything. Okay, so it's our decision. Perfect. Now, in order to be able to identify this A, I don't know how many decimal digits we want to use, but it doesn't matter. Make sure that your calculator is in degree mode. It's not. So I'm going to make it into degree, turning into degree mode. So then, second and quit. So I have 6 divided by tangent 70 degrees. Whatever that is. 2.18. And that is A. So A approximately 2.18. Good. Now we have several options. We can use a trig function, another trig function. We can, since we know the measures of the two legs, we can determine the hypotenuse using the Pythagorean theorem. I recommend using another trig identity or trig function. Which one? To determine C. So to find C, any trig function for the given angles. Anyone, please? Do we want to use another trig function for the given acute angles to determine C? Anyone, please?
we use cosine.
Very good. So we want to use cosine for which one?
20.
Yes, I recommend cosine 20, which is the adjacent over the hypotenuse. Excellent. So 6 over C, again, C equals 6 over cosine 20 degrees. Excellent. I think that's the easiest thing to do. Perfect. Thank you very much. So again, in the graphing calculator, make sure you have the mode in a degree mode. So 20 degrees, and the answer is 6.39. So C, approximately 6.39. Yes, you can double check, right? So 6.39 squared, so if I square this, I should get 36 plus 2.18 squared. I will not get exactly this because we truncated, we used an approximation, but I should get very close to this 40 ... Okay, so I checked my work. The hypotenuse squared, which is 40 plus 40.7690, and one leg squared plus the other leg squared is very close. So this is how we solve a right triangle. So now let's look at, where is my handout? Right here. Let's look at a couple of word problems. Like, for example, the hypotenuse of a right triangle is 3 feet. If one leg is 1 foot, find the degree measure of each angle. So let's start with this, and then we'll continue with others. So that's 24. So we have a right triangle. They're telling us that the hypotenuse is 3 feet. If one leg is 1 foot, find the degree measure of each angle. Well, of course, so if I have ABC, one of the angles is very well known, is the opposite of the hypotenuse, and that has to be 90 degrees. So they're asking us to determine the measure of this and the measure of this. Any suggestions on how to find A and B? Anyone, please? How do we find A and B? Any suggestions?
We can do sine of B.
Okay, so if we want to write sine B, that equals the opposite over the hypotenuse, awesome, which is 1/3. In order to find the angle, what do I need to apply to both sides? Because I'm asked to find the angle, not sine of the angle.
Natural log.
Careful, careful. So if I have e to 4x equals 3, I apply the inverse function, which is indeed natural log. Awesome, perfect. However, I don't have e. I don't have a base. I have sine b equals 1/2. What do I need to apply to both sides in order to determine angle B? You're on the right track.
Would it be cosecant?
Careful.
Is it arcsine?
Exactly. Again, let's take a look. Look at the graphing calculator, right? Look here. You see SIN, SIN inverse. You see log, log inverse. Natural log inverse. Cosine, cosine inverse. Tangent, tangent inverse. That's the reason why these keys are together in the same, one of them is using the second key, of course. So this is the inverse function of sine. It does not mean 1 over sine. We discussed that. These are the inverse trig functions. Excellent. Thank you. So we have to apply arcsine or sine inverse to the left-hand side and sine inverse to the right-hand side. Oh, sine inverse to the right-hand side. Exactly how we did it here. We had this function, we had to choose the inverse of it. We had this function, we had to choose and apply the inverse of it. I cannot apply cosine because cosine inverse is not the inverse of sine. If I had cosine, I would have applied cosine inverse. Good. So then angle B equals sine inverse of 1/3. Okay, now, since I wrote 90 degrees, I will use, yes, any questions? Anyone had a question? Since I wrote 90 degrees, I would like the answers to be in degrees. If you write here pi over 2, it's okay. But then you want to write the other 2 also in radians. So I'm going to share. Hold on, I have to start a new video.